This video goes over some examples of combinations of transformations. So recall, these are the equations that we have that contain all our transformation parameters. A represents our vertical shift or stretch or compression. C represents our vertical shift. K represents our horizontal stretch or compression. D represents our horizontal shift. So let's practice identifying the phase shift, domain, range, max value, min value, amplitude, and period. Those are the characteristics that you need to be able to identify to sketch your function effectively. So let's start with phase shift, which is just my horizontal shift. In this case here, I would have 75 degrees to the right. The next one is my domain. My domain is always minus infinity to positive infinity. My range is going to go between my maximum and my minimum values. So let's figure out my amplitude, which I know is just my A value, which is right here. That means that my max and my min are going to be 5 and minus 5. So that would be my range, minus 5 to 5. So now I've identified phase shift, domain, range, max value, min value, amplitude, and the period, the last one. So my period is going to be 360 divided by K, which happens to be 4, and 360 divided by 4 is 90. So I've got that horizontal compression of a quarter. Means that my trig function occurs much, much faster. Let's look at the second example. First thing I'm going to notice is that my expression is not factored here. I want to do that first before I start identifying anything. So here I'm going to factor out a third. That means that I'm really multiplying 180 by 3, which I think is 540. Let's double check. 0, 4, 2, 540. Good. So what this means here is now I know that I've got a phase shift of 540 degrees to the right. My domain I know hasn't changed, so minus infinity to positive infinity. And I'm going to look at my amplitude next before I do the range, which is 2. But here I need my maximum value and my minimum value. Now in the previous example, I didn't have a vertical shift. This time I do. So my maximum value is going to be 2 above that, and my minimum value is going to be 2 below. That allows me to figure out my range, which goes from -7 to -3. And then the last thing that I need to figure out is the period, which in this case is 360 divided by K, which is a third. So 360 times 3, let's do that here. 0, 18, 9, so 1,080. So let's do some examples of actually applying those characteristics and graphing them on the grid. So here, my amplitude is my A value, which is 0.5. My period is going to be 360 degrees because my K value is just 1. My phase shift is 180 degrees left, and my vertical translation is none. So let's go ahead and we're going to plot our axis of the curve. We've got y equals 0. Now I guess I'm going to need to do some labeling here. So let's see, 60, 90, to 180, 12, 270, 360. I don't think I need any more than that. Well, let's see, what do I have? I would have -90 right here. Okay. And I've got my axis of the curve. I know that my amplitude is 1/2. So let's make this equal to 1 right here. So this is 0.5. I've got minus 0.5, and then I've got 1. Okay, so my amplitude is 0.5, and I know I've got a phase shift left 180 degrees. I'm going to cheat a little bit because I know in order to go left for cosine, I would have to go here and then here. So what I'm going to actually do is I'm going to sketch on my parent function right now. So I've got here, 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 and here. So here is my parent function. Things are good. This is y equals cos x. Now I know that everything has been shifted to the left by 180 degrees. And I know that it's been shifted kind of about these maximum and minimum lines. So let's add these on here. So I've got my maximum and my minimum here. Max and my min. And what I'm going to know is that my end point is now 180 degrees to the left. So I'm going to put this point right here instead, right? So I'm finishing at a maximum, which is true for cosine, but I've shifted it 360 or 180 degrees to the left, okay? I'm going to do the same thing now for my other points. So if I go, let's see, 1, 2, 3, I know I would finish up here, also at a maximum, down, here we go. I'd be right at that minimum now, starting at 0. And I'm going to connect those dots here. That is 1 cycle. The example is asking me to graph 2 periods, so I am just going to follow the pattern on the other side as well. Trig functions are nice in that they repeat. And that is my trig function vertically compressed and shifted to the left by 180 degrees. Let's try another example. So here I've got y equals minus 3 sine 2 times x minus 30 minus 1. My amplitude is 3. My period is going to be 360 divided by 2, which is 180 degrees. My phase shift is 30 degrees to the right, and my vertical translation is up 1. So let's start on by drawing the characteristics that I need. So my axis of the curve is no longer at y equals 0. I guess I should, why don't we label my axes before I get too far into this, okay? Let's see, my amplitude's 3. I know I'm going to have to go up to 3, so let's just go up by 1s. 1, 2, 3, minus 1, minus 2, minus 3. I see that my phase shift is 30 degrees to the right. So let's make everything worth 30 here. So 30, 60, 90, 180, 270, 360, and we'll stop there. We're going to go up by 30s. Okay, now I can draw on my axes of the curve, which is 1 up, so it's right here. So I've got y equals 1. My maximum value is 3 above that, so right up here, I've got my maximum, and my minimum value is 3 below my axis of the curve, so right at minus 2. I've got my minimum. Now I know my period is 180 degrees, so I'm going to take my first point, which is sine, so I'd be starting right at on the axis of my curve, and I'm going to go to the right 30. Okay, my period is 180 degrees, so that means that my last point is going to be right on my axis of the curve at 180 degrees. Now I'm going to divide that distance in half to figure out the middle point. So between, oh, that's not right. This point should be 1 over because I've got a 180 degree period. So it's going to be right here. So now I'm going to divide that distance in 2 and I'm going to plot the middle point here. Now this is really where it comes into handy. I know my first point normally would be right up here, but I have this vertical reflection, so that I know that halfway between my first point and this middle point, I'm going to be at a minimum. In between the second 2 points, I'm going to be at a maximum. I can connect those, and then I can actually repeat my process one more time so that I can draw 2 cycles. So I've got here, I'm going up and then down, and here I've drawn a second cycle of my function. The last thing that you should be able to do is to be able to write equations for the function drawn below. Okay, so in order to do that, we need to figure out what each of the parameters are. Okay, so let's look at this first one here. What I'm going to notice is that this is my axis of the curve for the red one. So let's call this graph 1. So for graph 1, I know that I've got a vertical shift up 1. So that's fine. I know that's going to be the ending. What I also notice is that I'm starting at a maximum. So for my cos equation, I've got no phase shift. Okay. The next thing I need to know is how long does it take to complete one cycle. Okay, so I complete one cycle in 180 degrees. So let's write that down. So for cos, I've got no phase shift. Okay, and then I complete one cycle in 180 degrees. So that's going to allow me to figure out my K value. So my period is 360 over K. I know that my period is 180 degrees. So that's going to allow me to find my K value. From this equation, my K value is 2. So I've got my C value. I've got my K value. I have no phase shift. The last thing for me to figure out is my amplitude, or my A value, and I can do that by counting from my axis of the curve. So 1, 2. So because my amplitude is 2, my A value is also 2. So I can write that equation as 2 cos 2x plus 1. Now, the example asked me to write an equation for sine as well. I've got a couple options here. You might come up with a different equation than me. What I'm going to do is picture moving this point back to the start. So if I do that, that is a, let's see, I've got 30, 60, 90. So it looks like this is at 45 and 1. So that means that I would have shifted my original sine function by 45 degrees to the right. Okay, so for sine, I've got 45 degrees right. I also notice that I'm coming down to a minimum first. That tells me that I'm also going to have a reflection. So my cosine would look like this. I would have 2x minus 45 degrees plus 1. Those two equations would be the same graph. Let's try the second one. Okay, so right here, so for number 2, again, the first thing I'm going to do is look for where my midline of the curve is by drawing a line kind of right through those middle points. Okay, I see that my axis of the curve is at -2, so then I know I've got a vertical shift down 2. That's going to be my C value. Again, I am starting at a maximum here, so for my cosine, I've got no phase shift. Okay. How long does one cycle take me? Well, it looks like I'm going to go down all the way back up. It's 360 degrees. So that means my K value is 1, which is great. My amplitude looks like a half, which means that my A value is a half. So let's write my cos equation as 1/2 cos x minus 2. For sine, what I'm going to have to do, let's do this the other way. I'm going to picture moving this point to the right. Okay, so that looks like 90 degrees to the right. So that means that my original function must have moved 90 degrees to the left. And doing it this way, I go up to a maximum and then down to a minimum, so no reflection. I would have y equals 1/2 sine x plus 90 degrees minus 2. There are some examples of identifying characteristics, simplifying and sketching equations, and then determining an equation from a